to the Engineering Update. I'm technical editor Jason Lundberg, and in this week's episode, a spacesuit powered by urine, embedding tiny cameras in smart contact lenses, and NASA's flying saucer. No, seriously. Future voyages to Mars will need to address the physiological strain on the astronauts, the length of the trip itself, and ferrying the necessary payload to sustain human life for a protracted mission. The first two problems could be insurmountable, but to deal with the latter, NASA is currently testing its own prototype for a hypersonic flying saucer. Actually, the idea of a flying saucer, notwithstanding the X-Files or Marvin the Martian, isn't as far-fetched as it sounds. Back in the 50s, the military designed a prototype for a disc-shaped vertical takeoff and landing aircraft that looked suspiciously like a flying saucer. The Canadian-built Avro car was designed to take advantage of the Coanda effect, or the idea that a fluid jet adheres to a nearby surface and follows its contour, and the vehicle was conceived as a first-strike weapon should the Cold War turn hot and airfields become scarce. And while the prototype can only hover a few feet off the ground before wobbling uncontrollably, falling well short of the design specifications for a vehicle with a flight ceiling of 100,000 feet, the idea of a flying saucer took hold in our collective imaginations and the DoD. Luckily, the Cold War never turned hot, and the latest attempt at a flying saucer, the low-density supersonic decelerator, won't carry a nuclear payload or be used for military purposes. The disc-shaped vehicle will be able to ferry up to 100 tons to the Red Planet and, as the name implies, decelerate from a Mach 3.5 descent down to about twice the speed of sound. During its descent, the flying saucer will inflate like a pufferfish and deploy a 100-foot wide parachute to ensure a smooth landing. NASA plans to conduct the first test flights this June.
Though the Google highlight of this week was the availability of Google Glass to the public for the low price of $1,500, the more interesting news is that the company put in a patent application for what might become the future of the technology. This patent seeks to embed tiny cameras in the already patented smart contact lenses that would have similar uses to Google Glass. Things like taking pictures or recording what the wearer is seeing just by looking at it. It also has the potential to act as an assistive device for those who are visually impaired by alerting the person that there's an object in the way or identifying locations. It could even notify people via smartphone when it's safe to cross the street. It's not a new idea, at least not for Google, who has previously expressed their interest in a unique take on wearable medical devices that would utilize contact lens sensors to measure blood glucose levels in diabetics and provide real-time feedback. As someone who wears contacts, I can't imagine this will be the most comfortable option, since a tiny speck of dirt kind of feels like a knife in the cornea, but it has some pretty cool potential medical applications. Plus, it has the added bonus of not looking quite as dumb as Google Glass. Obviously, this is in the beginning stages, but we'll have to keep an eye out for the progress. See, little pun there? Little pun? No?
Staying on the topic of Mars, getting to the Red Planet will take almost a year one way, so astronauts will need to maximize their resources, including, as it turns out, their urine. Yes, ECN. Classy. Keep it classy. Resupplying a vessel hurtling towards Mars will prove prohibitively expensive, making basic resources like water a scarce commodity. And since urine is at least 95% water, and every astronaut should release at least 1.5 liters of liquid waste a day, we'll need to recycle and reuse this resource. Urea is the main nitrogen-rich component in urine, and this substance can be used to power, among other things, the astronaut spacesuits. Astronauts aboard the International Space Station already recycle the urine, extracting approximately 75% of the water content for their own deposit. Yes, this means they drink their own, well, you know. By next year, NASA scientists hope to be able to extract 85% of the water content from urine and eventually 100%. In lab tests, researchers filtered the urine through a bioreactor and they were able to convert about 86% of the urea into ammonia, which can be used to power a fuel cell. Yes, it's every bit as nauseating as it sounds, but the process could ensure that an extended Mars mission has enough power to get there and return home. That concludes this episode of the Engineering Update. Be sure to check us out on Facebook, Twitter, and LinkedIn, and you can catch past episodes on ecnmag.com. For the ECN channel, I'm Jason Lundberg, and thanks for watching.